as you know, in this class, we like to break things down. You know, there's this many steps to make a histogram. There's this many steps to make a control chart. And the same steps that applied for variable control charts are going to apply to attribute control charts. Step number one, we have to decide if we're talking about pumpkins or whatever, what is our quality characteristic that we're concerned about? For pumpkins, we could just say, does it have a bruise on it? Or we could say, does it have a scratch on it? Or we could say, is it moldy? Or we could say, is it any of those three, in which case it's going to be non-conforming. Okay? And then just like we did, whether you realized it or not, for the variable control charts, we determined the subgroup size. And there's a little trick here, little method to figure out if you don't know, like if you're starting from scratch, you're solving a quality problem on your own, you're going independent, and you're like, I don't know what my sample size should be. I've got thousands of pumpkins. I've got 5 farms. What do I do here? This is the formula that we can use, and we'll have an example in a couple slides where we apply it. But just briefly, we're going to solve for n. What is n? You know, no one told you n. No one gave you data. And then we need to get an estimate of the p-value. I think a better word here would be proportion. What is the proportion non-conforming? We're going to simply multiply that times 1 minus p. And then we're going to look up this z value. So if we want a 95% confidence limit, we're going to punch in 1.96. And you'll have these slides. And we're going to calculate E. And what is E? It's the desired precision times an initial p-value. There's a bit going on in this formula, but if you just break it down to these 4 things, it's simple algebra. Okay? So the desired precision, in the example I have coming up in a couple slides, you'll be given the desired precision. And you know what precision is, right? It's like we were saying, if you have a dartboard, you know, this is more precise than this. So you'll see often it's like 5% precision, 10% precision, and we'll use 10% for the example coming up. So we're going to, the key is for E is not desired precision. E is desired precision times the initial P. I always have a couple people who just punch in the desired precision right here, and then they're done. And they forget to calculate the initial P. And to get that initial P, we're just going to get at least 50 samples. And we're going to determine how to sample those. Eventually, we'll collect our data. And ideally, you have at least 25 subgroups on your chart. Remember, subgroups is the x-axis. If this is our center line, these are our control limits subgroup. So you would have up to 25 observations. And why do we say at least 25? Well, because you can't really see a trend until you get enough on that x-axis. It makes sense, right? If you only had 5, you would not really get a chance to see 2 proportions or a steady increase. At last, we're down to our handy-dandy central line and control limit equations. They look pretty simple, right? Basic math, you only need 2 items. Your p-bar and your sample size.